How to factor the greatest common factor, part 2, on Aiken's How to Math. In part 1 of factoring out the greatest common factor, we had gotten to the point where we could factor out not only the biggest number that would go into each term, but any variables each term may have in common. And for this one, the last one that we did, we saw that they both had an x in common. So not only did we have to include the 8, we also had to include one x. We need to look at an example where you have more than one variable in common. For example, this one right here has two x's. This exponent is telling you that there are two x's being multiplied together. This one, there's only one x, so the maximum number of x's you could pull out was only one. We need to look at an example where you can pull out more than one x. So again, we're going to factor this, and when somebody asks you to factor something, the very first thing you look for is the greatest common factor. I need to find the biggest number that will go into 6 and 24. That number would be 6. I put it on the outside. I need to see if they have any letters in common. Both of these have an x in common. I put an x on the outside as well, and then I need to see how many x's they have in common. This one right here has 4 x's, this one right here has 2 x's. The maximum number of x's I can pull out of each one of them is 2. So on the outside I put x squared and I make my open parentheses. I could pull at least one x, 2 x's, but I can't pull 3 x's out of this one because this one only has a total of 2 x's right there. So the maximum or the greatest common factor is 6x squared. How do I get what goes inside the parentheses? I divide each one of these by 6x squared. And that's how I get what goes inside the parentheses. So 6 divided by 6 is 1. When you divide, you subtract your exponents. 4 minus 2 is 2. I have 2 x's on the inside left over right there once I divide these two terms. This one right here, 24 divided by 6 is 4. 2 minus 2 is 0. I have no x's left over. So that's what it looks like when you have more than one variable that you can pull out on the outside as part of your greatest common factor. Let's look at another example like this one. In this one right here, it doesn't matter how many terms you have, you still find the greatest common factor, the biggest number that will go into 15, 6, and 21. Looks like it's 3. So I want to put a 3 on the outside, and I'm going to look and see if they have any letters in common. Well, they all have an A. Put an A on the outside. How many A's do they have in common? This one has 5, this one has 3, this one has 2. The maximum I can pull out of each one of these is 2 because this one only has a total of 2. So I put 3a squared as my greatest common factor. I make an open set of parentheses, and how do I get what goes inside the parentheses? I divide each one of these terms by that greatest common factor. I take this one, divide it by 3a squared. I take this term, divide it by 3a squared. And I take this term and divide it by 3a squared. That's how I get what goes inside the parentheses. So let's divide this one first. 15 divided by 3 is 5. After I subtract these exponents, I'm going to have 3 a's left over. 6 divided by 3 is 2. After I subtract these a's, I'm going to have 1 a left over. Minus 21 divided by 3 is 7. After I subtract these, I have no a's left over there on the end. That's what this polynomial looks like after you factor out the greatest common factor. Let's look at an example where you have more than one variable. So in this one, again, they're asking me to factor it. The first thing I look for is the biggest number that will go into 4 and 16. I write that on the outside, and then I look and see if they have any letters in common. Well, they have an X in common, and they have a Y in common. I need to put both of those letters on the outside out here. I make my open parentheses, and how do I get what goes inside the parentheses? I divide each one of these terms up here by this greatest common factor because they had an x and a y in common. I can only pull one x, even though this has x squared, I can only pull one x out of each one of these, and I can pull a y out of each one of these. So let's divide each one of these by 4xy. Divide this one by 4xy. 4 divided by 4 is 1. Subtract my exponents on my x's. I have one x left over. Subtract my exponents on these y's. I don't have any y's left over. Plus 16 divided by 4 is 4. I subtract these x's right here. No x's left over. Subtract the y's. No y's left over. I close my parentheses, and I have factored out the greatest common factor for this one. One more. Not only do you need to see if they have letters in common, you need to see if it has signs in common. Because not only will a 5 go into both of these, not only do they have x's in common, they've got this negative sign right here. Both of these terms have a negative sign in common. If they have it in common, you have to include it in the greatest common factor. So I put a minus sign on the outside. I put a 5 on the outside because 5 is the biggest number that will go into both of those. I put an x on the outside, and I see how many x's I can put on the outside. The maximum I can pull out of each one of these is 2. X squared goes on the outside, and I make my open set of parentheses. So my greatest common factor is negative 5x squared. How do I get what goes inside the parentheses? I divide each one of these terms by 5x squared. Divide this one by negative 5x squared. A negative divided by a negative, positive. 5 divided by 5 is 1. X to the 4th power divided by x to the 2nd power. I subtract my exponents. I have 2 x's left over. Again, a negative divided by a negative is a positive. 10 divided by 5 is 2.